I think, Soman, I think we should get started. It's already, 3 minutes past the hour. Okay.
Okay. So those who have joined today, just briefly, I introduced for them because already some introduction has given in last class. For those who have joined today, that Professor Nalke Sen, the eminent professors in applied geophysics, applied seismology, is a very renowned, and he has been working in many fields, including that AI and machine learning. He is specialized in inverse theory and he is globally known. He has written 2-3 very well-known reputed books. There are many numerous technical literatures, peer-reviewed papers, which are editors of many reputed journals like Scientific Reports. There is Geophysics is one of the sounded journal in our field, and very top journals is editors, and he has a huge experience in this field. He is a pioneer of very fast simulated learnings, and he has been working this AI and machine learning since I think more than 20-30 years back. Still he is doing, and we are fortunate that we are having that renowned professors like Professor Sames, and yesterday's lecture was excellent, and those who have missed, you can also start with this interact, and those who have students, your colleagues, friends, those who have joined, you attended last class, so you can consult them if any problems you find during or reading that PDF already he has shared. And I hope that you can interact with sir and get enriched in this field, because he is a frontier researcher in this field, and he is very widely known people. So I invite Professor Sens for his second talks, and thank you. So I can,
okay, so yeah, thanks, Soman. I don't think I need to introduce me before every lecture, but that's okay. Yeah, so I mentioned
this meeting is being recorded.
I mentioned on Tuesday that I would like you to form groups, and there'll be homework and assignments, in-class assignments, and you can do those in groups. And I think since there are 80 students registered, so I would say that no more than 8 students in a group, so we can handle 10 groups there. So form your groups, make sure that the students are from different disciplines. That really enriches the learning process, and we can go from there. I think there is a yes, Santosh, did you have any comment?
No, just hi.
Hi, okay. Sir.
Yes.
Sir, today I missed the last class, sir. So
yes.
Yes, sir. I was introducing in chat box, so that's why I was
okay.
reading something.
Okay.
So
yeah, normally in my class I like to basically have my students introduce themselves. Do you think we should do that, Soman? I think it's better.
Yes, it is better, because
yeah.
I was also planning these things, but things are not getting settled from other side, so I was waiting for that.
Okay, so what you need to do is basically unmute yourself and put yourself on video, and just say like why, what, like which year you were in and why you're interested in this course. Make it very brief, because I think right now we have 60 people already here. So let's go one by one. Somebody want to call their names, or you can see that you can see them on the screen, right?
Vivek Singh is here. Vivek, please.
Just look at who all are in the class.
Yes, Vivek Singh already joined.
So the goal here is to essentially go over some of these topics like the motivation and human learning, artificial intelligence, and some of the terms that you come across and what they mean, like what is machine learning, what is the history behind it, what are the different types of machine learning. You hear about supervised, unsupervised, semi-supervised, and reinforced. So I'll just briefly define those, and then we look at these two ways of doing machine learning, classification and regression. And just want to mention to you the kind of background that you need for learning machine learning. These include, excuse me, linear algebra, statistics, computing. And of course, I should have asked you, when I asked you to introduce, I should have asked you to tell me, like, if you had any experience with computing. Even if you don't have had any, if you never had any experience with computing, don't worry, you'll catch up, okay? Because I'll be giving you pieces of codes to work with. And then, of course, shallow and deep learning. Okay, so I found this quote in a, this is actually from a TV program called Westworld. And this is the kind of view people have about how human beings learn and learn different things. Now, just to tell you that this is too simplest. This is very simple statement of what actually is going on. So what he says is that the truth is that a human is just a brief algorithm, 10,247 lines. They're deceptively simple. Once you know them, their behavior is quite predictable. Now, in these words, basically what he's trying to say is that if you learn how the human beings learn, then you can use that to teach a machine to do some of the tasks that the human beings do. And that is the main idea behind machine learning. But I would not really take each word stated here for granted. For example, is it really 10,247 lines and so on? But the basic idea is that there are ways that human beings learn, and if we learn how we learn, then only we can teach a machine to learn things that we do. So then, if you think about what is intelligence, Wikipedia says that it's an umbrella term that is used to describe a property of the mind that encompasses many abilities, such as your capacity to reason, to plan, to solve problems, to think abstractly, to comprehend ideas, to use language, and to learn and to solve problems. Okay, so these are the things that that an intelligence basically lets you do, and we actually develop over the years. When you're just born, you don't have any way to reason things or plan things, but as you observe how people are actually operating, that is basically what teaches you as to how to do different things. Okay. So, human learning involves several steps, and we learn in many different ways. So we learn from things that happen to us, from our experiences. This is very important, So, for example, when you were a kid and if you touched a hot oven, then you realize that, oh my God, this is red, so it might be hot. And then next time you don't touch. So from experience, you learn good and bad things. For example, when you see lightning occurring and you know that thunder might be falling right after that, and this is our common observations. At that point of time, we really don't know what causes lightning and thunder, but everybody knows that lightning is followed by thunder. Okay, whether it's actually, well, now that you have good knowledge of physics, you know that light travels faster than sound, so that's why you observe lightning first. But anyway, these are some of the things that you basically learn from your own experience. We can say that we have learned these things because we have acquired appropriate responses for them. So we cover our ears when lightning strikes, then we know we want to avoid basically, and then we don't want to be basically being bombarded with a huge sound. And in fact, we try to avoid telling lies and we dance. So these are some of the things also you learn from experience and observations. It's learning is acquiring relatively permanent change in your behavior through experience. The previous example that I gave you is exactly that. You observe something and then you react in future based on your experience. And that really helps us to modify our behavior based on what we know. And it does not apply just to human beings, but also to animals, especially, if you observe a dog or a cat, you can actually see how quickly they learn different things. Not everything that human beings can learn, but few things they learn, and they learn it really well. So human learning can be, is basically uh, human learning can be described by many different processes. For example, observational learning. So you learn by watching others engage in different behaviors. For example, if you want to learn how to dance, then either you watch a movie or you have your teacher demonstrate some dance steps to you. Then we have associative learning. This is the learning by establishing connection between events, okay? Then classical conditioning. This is the method of teaching association between two different stimuli. We learn the connection between lightning and thunder, the one that I already talked about. So classical conditioning is an example, or rather, lightning and thunder is an example of classical conditioning. And then there's something called operant conditioning. This is the method of teaching associations between behaviors and consequences. Okay, so this actually uses rewards and punishments to strengthen or weaken behavior. So if somebody goes and steals something from a grocery store, then that person is punished. On the other hand, if you basically go home and tell your parents that you got all A's, then maybe your parents will give you a reward. So, you have to be able to know the connection between the telling lies and losing credibility and friends. And that's why we learn to tell the truth. Now, this is my favorite picture. I'm sure some of you have already seen this. And this basically is the pyramid that tells you how human learning progresses. You learn 10% of what you read, okay? And 20% of what we hear, 30% of what you see, 50% of what you hear and see, 70% of what we discuss with others, 80% of what we experience personally, and 90% of what we teach to others. Now, this is basically very true, and I have actually learned this from my own experience. Now, if you see a professor who is very young, who just joined the department, and then he comes to lecture, and of course, he may be shy to start with, but even otherwise, he or she may not actually know a lot. But then you may think that this is a stupid professor. He just doesn't know how come he got hired in the department. It's a waste of time. But maybe come back 5 years later and you can see that the same professor can talk to you about many different things because he has learned so much by teaching. And that's why, teaching is a very good profession where you basically teach yourself before you teach it to the others. And the way you teach yourself is to the extent that you don't get confused when you're talking to the students, because students come from all different backgrounds and they can ask you a lot of questions. And first of all, it's not a shame if you ask me some question and I cannot answer. It's not a shameful thing. I mean, there's no way everybody can learn everything, and everybody cannot think about the same set of questions. But if you are a teacher, then you go back and you dig really deep into the problem, and you can find out answers. Not only that, you learn a lot more things associated with it. So this is basically the pyramid of learning for human beings. Okay, and a little bit about physiology, which I'm not an expert on, and I can tell you that a lot of these machine learning applications, they do have some connections to physiology, but that is sort of like at the high level. It's basically in details, they're quite different. So we talk about neuron, and this is essentially a nerve cell that is electrically excitable. And it communicates with other cells via specialized connections called synapses. And a group of connected neurons is called the neural circuit. So I think most of you have heard the name neural network, and essentially in neural network, we try to emulate this neural circuit and in a very, very crude way, okay? So brain has a network of fiber pathways consisting of 100 to 10 to the power 10, 100 billion to 10 to the power, basically 10 to the power 10 neurons. So you'll see that same thing will apply when you're trying to build a machine or build a neural network to learn some complicated procedures. In that you can see that the machine becomes huge, and you have a lot of neuron to be able to capture some of the features in the machine. So this is all I wanted to say about the physiology, and if anybody wants to dig deeper into it, they can go ahead and do that. But the idea came from physiology. So artificial intelligence is the simulation of human intelligence. First of all, we have a systematic attempt to simulate human intelligence, but I don't think we really understand in as much detail as we would like the human intelligence itself. And therefore, of course, that doesn't mean we should not even try to simulate. Whatever little we understand, we try to simulate by machines, and with the hope that some of the routine tasks can be done very efficiently using those machines. So AI is now, it's basically a branch of computer science that emphasizes the development of intelligent machines. I think everybody has had some experience with using computers here in this room. So you might wonder, like, how it all came into being, and wouldn't it be nice if you could basically do many things that cannot be done without actually telling the computer to do it. So, for example, when we were when I started my career a long time ago, when the computers were very, very tiny, tiny in the sense that their capabilities were not that strong, but then the size was huge. But in any case, at that point of time, when I was writing my book, and then I thought, oh, wouldn't it be nice if I could just dictate and let it get typed automatically? Well, that didn't happen at that time, but nowadays you have a voice recording where you speak to the computer, and then it automatically gets translated, and it gets written down. So things happen, and there's an algorithm that does that, and we will talk about that. So artificial intelligence involves using computers to do things that traditionally require human intelligence. Okay. So this means creating algorithms to classify, analyze, and draw predictions from data. And it also involves acting on data and learning from new data and improving over time. So this is very, very important. Artificial intelligence involves acting on data, learning from new data, and improving over time, just like we human beings do. So I think I am 1 minute past the time, right, Soman?
Yes.
So I'll stop here, and I will continue again tomorrow with this, okay? And in the meantime, if you have a question, I mean, I've hardly spoken anything about AI, so if you have any question, you can either ask me or you can send messages. I would strongly recommend that you use Piazza, and you can even put your questions up there. Have your own discussion groups, but I really don't know how many people are actually going to be attending the classes, because 80 people are registered, only 45 people are attending. So I really don't have a clue. But in any case, let's assume that 50 students are attending. So form your groups and let us know by next Monday. Okay. Because we will start to do some exercises, and it will be very important that you form your groups. Okay. Any question, a comment? Yes. I'll try to finish this lecture, and then if there is time, I will do tutorials. Okay. Okay. Yes, everybody should have Anaconda registered on their laptop. Okay. And then I'll tell you what are the next steps. Okay. Okay.
Thank you,
Okay.
sir.
Bye-bye.
If I already have Python and other module, all the modules, then do I need Anaconda?
No. If you
Okay,
have
okay.
already Python, don't worry about it. If you're already used to programming in Python, then it's okay. All that I wanted to have you do is to have access to Python. Okay. And Anaconda comes with a standard set of libraries, and later on during the course I may ask you to install a few other libraries like Keras and TensorFlow. Okay. All right. So I'll then see you tomorrow. Okay.
Thank
All
you,
right.
sir.
Okay, sir.